In this video, we're going to talk about hot versus cold observables, as well as how we can share and publish our existing observables. So first of all, let's define hot versus cold. Hot versus cold isn't something you're going to see in the source code. It's not something that you're not going to instantiate a hot observable versus a cold observable. It's sort of a just general concept that is good to have in the back of your mind when working with observables, thinking about the scenarios that they're used in. And whether observable is hot or cold, it affects how you would use it and how you'd expect it to behave. So it's sort of this, like I said, just general sort of, sometimes nebulous. There have been many articles written about hot versus cold, but it's this general concept that can be used to help you understand what's going on and what your expectations are when you subscribe to one. So let's go ahead and define the terms. A hot observable is an observable that, just a general concept of what you're subscribing to that's going to produce events regardless if you're listening. Let's see an example of a hot observable. Let's hop over to source client and open up our autocomplete and reactive extensions. This is a hot observable. The reason it is because the keyup event is going to be fired regardless of whether or not you subscribe to it. So the expectation here with a hot observable is that you do not expect to receive historical data. You only expect to receive data the moment you plug in to that stream. So again, the stream here is the keyup event on the title element. But we have no expectation to receive historical keyup events. It'll only start providing these values once we're connected to it. A cold observable, on the other hand, is, well, we can see a whole bunch of them. If we look in our built-in, these are all cold observables. Maybe if we go back to our first example, we see even a better, more explicit example of what a cold observable does. A cold observable, when you subscribe to it, that's when it starts doing something. And you expect to receive every single item from the start. And if I subscribe to it again, I expect that second subscriber to get all of those values from the start to the end of the sequence. So every time you subscribe, the generator is called and it generates those values from start to finish. Now, they might be delayed. For example, often people think that the interval is a hot observer because we subscribe to it and then we get an item and then another item after specified time and so on and so on. And they kind of think, oh, that must be, a hot observable. The answer is no. Every time we subscribe to that interval, we get a new set interval invocation. We have a new timer. We saw that back when we were talking about subjects, how every time, unless we use the subject as a proxy, every time we subscribe to that interval, we got a new set timeout. So you see, in this example right here, the example we talked in the last video, we actually successfully turned what would traditionally be a hot observable or a cold observable into a hot one by sharing it using a subject as a proxy. So why is this important? Again, it's a very nebulous idea. And there are very, very long blog posts written about really getting into the details of what exactly, in exact language, hot versus cold is. But so you kind of have to get a feeling for it while you're working with it. But I want people to keep in the back of their mind what's hot, what's cold. It changes your expectations. You subscribe to a cold observable, you should think, okay, well, that means that I'm going to get every single value from start to finish, and I have no expectation of missing a value. You subscribe to a hot observable, however, and you think, well, actually, I have no expectation of receiving every value. When we subscribe to a keyup event, we have no expectation of receiving every single historic keyup. And that's what you should be thinking of. So, yeah, how can we use this to our advantage? What does this help us accomplish? Well, there's a lot of great examples here that I can put up. Let's talk about the publish method. So let's go ahead and create a new file, and I'm going to do example 05, and I'm going to call this hot cold.js. And then I do have gulp running, by the way. Make sure that we do indeed get our hot cold built once we save it. Might have to refresh that. Oh, there it is. And let's go over here and let's npm run node mon, and we're going to do build / example 05 underscore hot underscore cold.js. And now we have node mon running. And let's go ahead and grab these guys here too, since we're going to be using both of those. Okay. So let's talk about converting a cold observable into a hot observable. So to do that, we can use the publish method. So I can say const interval equals rx.observable dot interval 1000, and let's take the first 10 of those. Then what I'm going to do is I'm going to take 10, but then I'm going to do, well, let's show the example first as it is, without publish. So let's set timeout on 1200 seconds, and let's do interval, and let's do subscribe, create subscriber, and we'll do 1. And then let's also subscribe at 3 seconds. All right, so what happens? In 1 second, we get our 10 items. And then in 3 seconds, whoops, this should be called 2. In 1 second, we'll start getting our 10 items. And then in 3 seconds, we start getting our 10 items again, right? But starting from the beginning. So we have 2 set intervals going on at once. Let's go ahead and change that. Let's make this hot. We do that with the publish method. And for the publish method, it returns what's called a connectable observable. Notice how it just saved and we're not getting any output. In fact, we just got a clean exit. The interval never started. So let's go ahead and connect to it. It's a connectable observable. It means that what happens is we create the observable, we call the publish method on it, and it gives us a new connectable observable that won't subscribe to the underlying observable until I call interval.publish. Or sorry, interval.connect. Now let's see the behavior we get. So we missed the first value. 1 missed the first value. Then 2 subscribed. Now 2 is getting the exact same values as before. So this has some important connotations here. First of all, the moment we called .connect, this observable executed and started doing its thing. We could see that because we missed the first value. Remember, the first value of interval is 0. We missed the first value. Let's flip this on its head. Let's say set timeout and say connect, and we'll connect after 5 seconds. So we get nothing, 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 and then after 5 seconds, which hopefully I can talk long enough for that, it connects. And once it connects, then it creates the interval. So notice that the subscribe method is not causing this interval to ever execute. It only starts executing when connect is called. And then when connect is called, these 2 subscribers share the underlying observable. We have successfully created a hot observable from a cold observable. Why might you want this? Well, let's do an example here. Let's say I create a new observable, const events, or how about const chat messages equals rx observable, or sorry, new rx observable, and we'll pass an observer, and we'll do we're going to pretend that there's this this code isn't going to run. I'm pretending that we're working with socket.io, so I'm going to use this imaginary socket variable on chat message, and then message observer next message. Now, here's the problem with chat message. First of all, it's a cold observable. You might be going, oh, hey, well, that looks like a hot observable to me. But in reality, it's a cold one. It's cold because our socket on is subscribed to over and over and over again every time we subscribe to our chat messages. We can see that. We can see console log subscribe. And I can go ahead and I'll just stub this out so it runs. So I just stubbed it out so it'll execute. And if we do chat messages dot subscribe, create subscriber 1, and then create subscriber 2, we'll see subscribe. So we did it twice. Now let's turn it into a hot observable. So I'm going to say .publish. But now we have a problem where it doesn't actually do anything. It doesn't actually subscribe at all. So that's going to cause an issue. So the issue is that we don't subscribe to this socket on chat message until, well, ever right now. Previously, it was every time we subscribed to the chat messages observable, but now it's never because we never connect. And what we could do here is we could say chat messages, which, by the way, that money sign should be on the other side, .connect. And now it only subscribes once, and now both of these subscribers get the same values. But why is that important? Well, it's important that we execute this observable once so that we latch on to the chat messages. Because what if we wanted to queue up all the chat messages that were received while nobody was watching it? What if these two subscribers came in 10 seconds, 100 seconds, a million seconds away from when we actually connected, or when we actually created this observable? We want to make sure that this generator function runs and is running so that it can subscribe to our socket event so that we don't miss any events. All right, there's a couple other ways to do publish. Similar to subjects, and these will use sync and deferred subjects respectively. So if I say const simple equals new Rx observable observer, and let's do publish last first. So I can say observer.next 1 observer next 2 observer complete, and then I can say const published equals simple, and I'll say publish last. And then I'll go ahead and say, I'll do this in two ways. I'll do published dot subscribe, create subscriber 1, and then I'll do published dot connect, and then I'll do create subscriber 2. And so we get 1 next 2 and 2 next 2. So you see, no matter what order we subscribe these to, before we call the connect, we always get the last value published out. If I never completed this, it never executes. It never runs the last. So this is exactly like the async subject. In fact, the publish last method uses the async subject under the hood. It waits for you to publish everything and then complete, and then it'll always return the last value. So you see, even before we connected, we still only got the last value. And even after we connected, we still got the last value. So what about publish replay? We can publish replay 2. Exact same concept, literally the exact same concept, except we have a couple of differences here. In this case, we're using a basically a replay subject. And so you see 1 gets everything because 1 subscribes before we connect. So remember, this subscription does not cause this to execute. Only .connect causes this to execute. So we're subscribed on 1 before we connect. So 1 gets 1, 2, and 3, and then it completes. However, after we connect and we've generated the sequence and we resubscribe with 2, 2 only gets 2 and 3 because we only published replay 2. Okay, that's well and good, but now we have to deal with the fact that this is a hot observable that will be executing regardless of if we have any subscribers. So how do we clean up? How do we dispose? And there's a couple ways to do it. We could disconnect the publish stream, and that will cause whatever callback our observable has. So if I said return console log disposed, then we can see that it gets disposed after this complete, of course, but we can nuke that complete. And we get 1, 2, 3, blah, blah, blah. And if I did const sub 1 equals that, and const sub 2 equals that, and I said sub 1 dot unsubscribe, and sub 2 unsubscribe, and did that, notice how we are unsubscribing both of our subscriptions, but we're not disposing our observable. So the only way to dispose of this is to get a reference to what's returned by connect. So I'm going to call this connection, and to call connection.unsubscribe. By doing that, we're now disposed. So that we're in control of when this hot observable starts and when it stops. But that's not necessarily the behavior you might want. So let's talk about refCount. So I'm going to go ahead and I'm literally just going to grab this. And actually, I'm just going to copy and paste this whole thing mostly. So refCount is a way to automatically handle the connection and the unsubscription of a connectable observable. So let's go ahead and nuke that. We don't need this anymore. Let's, instead of doing that, let's say simple.share. Or sorry, simple.refCount. Or simple.publish.refCount. So check that out. We got 1, 2, 3, and then disposed. But we only got that for the first one. Of course, because I'm not doing a publish replay. So if I do a publish replay on 2, our second one gets the last 2 items as well. The refCount, what that does is it automatically handles connecting to a connectable observable and disconnecting from it when it's done. refCount will connect to the observable on the first subscription, and then it'll disconnect once the last subscription has unsubscribed. So you see, dispose is being called there because both of our subscriptions were unsubscribed. If I take off the second one, though, notice disposed has not been called. So the observable is still hot. It's still listening to events. There is a publish refCount. It's such a common thing. Doing this, doing publish.refCount. Again, we only get 1. We don't get 2 because the second one connects is when we connect to the observable, where it produces these 3 values. But then when 2 connects, there's no values being produced. Remember, it's a hot observable. It's not going to rerun this function just because we connected another subscriber. But this is done so often that they made another operator that does the exact same thing. It's called share. Share has the exact same behavior as calling publish followed by refCount. So share will connect to this observable on the first subscription and it'll disconnect on the last subscription. I want to point out that in Rx version 4, there was a share replay operator. However, you could probably figure out how to implement this operator no longer exists, but you can probably figure out how to implement it. And you actually saw an example just a second ago. You do a publish replay followed by a refCount. And that has the exact same behavior as the old share replay operator. And that's it. That is hot versus cold observables, connectable observables, publish, share, and refCount. They're very, very important, especially when you do things like connect into a socket, socket.io thing or a WebSocket or something like that. You want to take your code and you want it to be hot. You don't want every single subscription to result in a resubscription to the underlying data source. You only want to connect to the underlying data source once, and then share it between all your other subscribers. And you can do that with these operators. You could also do this for computationally expensive operations. Let's say you have this huge workflow that does 10 million things. Well, you want to be able to subscribe to it multiple times, but you don't want to repeat those same operations over and over and over again. Well, the answer to fixing that is making it hot. Calling publish on it, or calling share on it, then calling either refCount or manually connecting to it if you want that operation to happen, that big, long operation to happen. Before anybody subscribed to it, simply make it connectable and connect to it. And then that operation is done, and then it's shared by everybody else who connects into it, assuming you have a publish replay or a publish last. Anyway, so stuff and things. This is the end of our overview of RxJS core concepts. So in the next section, we're just going to talk about different operators. We're mostly going to be just here in our node example, and we're going to talk about the most common operators that you should always have in the back of your mind when you're creating these workflows. So we'll see you then.